Chapter 2 of the U.S. Army Corps Engineering Rehabilitation and Design of Railroads, CI 885002, AFM 321125, Chapter 2, Determining Traffic and Load Carrying Requirements. 1. Introduction. The first step of designing railroads is to determine the type of the volume of the traffic to be handled. The traffic type of the volume generally govern the size of the arrangement of the terminal facilities, the number of the auxiliary tracks required in the track structure design. The traffic handling capability of an installation must cover the existing foreseeable requirements that use included. Mobilization outline, loading, training, exercise, installation, supply, routing, traffic. Once assembled, data of the traffic volume type of this should be reviewed, approved before proceeding of the design process. 2. The traffic type information gathered from the traffic type should include the type of the cargo to be handled, the type, the size of the freight car to be used, the manner in which the cargo will be loaded and unloaded, the height of the width and the height of the width of the cargo, the clearance, the requirements, handle of the open cars, flat cars, and gondolas, special requirements, restriction, loading, unloading, moving the cargo, especially when handling hazardous cargo. F. From information required from the loading facilities, determine the planning of design of the loading facility covered in Chapter 8 of the Table 2.1, listing the common cargo types along with the freight car's loading facility usually required in the handling of the cargo. Figure 2.1 shows the common type of the cargo types. Table 2.1. Alright, we have a light wheel cargo, heavy wheel, light track, ABC Bradley 5.0 and quarter ton to 2.5 ton, auto track, bi-travel level, circus train unloading. Facilities multi-envelope, common cargo types and loading requirements. You have your facilities as permanent end ramp, which light track, heavy track, tankage, engineering equipment, wheel and track, flat car. The tops are flat cars for the permanent end ramps, multi-level ramps, and the CFOCs are containing loading facilities. The flat car gondola has facility required crane loading and unloading at crane access. Tanker car pumping and dumping on the pipe of the network. The POL handling of the equipped with the spill containment. A box car side loading ramp equipped with spill containment. COFC container loading facility equipped with spill containment. Boxcar, once again, side loading ramp or meeting with the QD requirements. CFOC container loading meets the OD requirements. Boxcar, miscellaneous brake bulk, side loading ramps, forklift on dock, staging area needed to the dock. Here is common freight cars. You see the boxcar, the flat car, the gondola, the hopper, and the tanker car. 3. Traffic volume. In addition to the traffic type of the traffic, the amount of traffic must be estimated for the information should include a maximum number of cars for each traffic type. The might installation at one time include empty cars. Longest trains that needs to accommodate into or out to the installation. Maximum number of the cars that might of all types that might be in the installation at one time, including empty cars. Maximum number of cars that each loading facility terminal might require to handle in a single loading unloading cycle. 4. Wheel loads. Track structure design generally. The track structure design greatly influences the magnitude of the wheel loads the track must support. When different cars, types of cars, and loading may be handled abroad on the installation for planning purposes. The design wheel is based on the heaviest type of the load of the car that will be most commonly run over the particular track. In many cases, the wheels from the engine, either the Army owned or the commercial carrier, will represent the heaviest single load on the track. However, the number of the wheels of the load of the car typically far exceed the number of the locomotive wheels over the much of the track. Is therefore magnitude of the car wheel that should be given in the most cases. In either case, both loading conditions must be checked for the final design. The design of the wheel load usually obtained by the taking of the static wheel load from the heaviest commonly used car, adding the car factor accounting to the dynamic effects of the travel speed combined with the track of the wheel irregularities. Table 2.2 suggests a design wheel loads planning purpose. To use the table, select the car type of the common and most closely matches the heaviest car in the common use over the track. For the terminal areas around the installation where the speed is usually limited to 10 miles an hour, select the design wheel load. The common load of 10 greater than equal to 10 miles an hour. For connecting the installation commercial carrier with the train speed will likely to exceed 10 miles an hour using a column 10 to 25 miles an hour. For track most likely used for the engine during the switching, and most empty cars will be stored that will otherwise occasionally select the commonly labeled light use. There's design limitations to light use, and then back from the far right to the left, greater than 10 miles an hour and 10 miles to 20 miles an hour. The wheel load for a 40 ton at 10 to 25 miles is 20,000 pounds. Box cars, basically it's half divided rate by um, it shows the tanker gallons and 10,000 gallons. Locomotive, the G. Hoppers, your gondola, and your tanker. Loc 5. Locomotive tractive effort. Definition of the design of railroad route is necessary to how the pulling of the force of the locomotive is capable of exerting. The pulling of the force is known as the traction effort. Traction effort is maximum starting and diminishing as the speeds increase. B. Application of locomotive tractive effort along with the routine gradient and curvature will largely determine how many cars can be pulled over the route of the single train. For any other perspective, locomotive traction effort minimum desired of the train size determine the maximum grade curvature tolerable of the given route. Traffic effort. The traffic effort of the data are available on military and commercial locomotives. When they're not ready to obtain, the data can be estimated the locomotive weight of the engine house, horsepower rating. The procedures are covered in Chapter 3 and Paragraph 5. 6. Traffic and terminals. Once the traffic holding the requirements have been identified and described in Chapter 2, paragraphs 1 through 3, processing, design, terminal support facilities in the beginning. The number of size and length required for the facility serving the track is based on these traffic requirements. Chapter 8 covers the planning and design of terminals. Chapter 7, surface source of the traffic information, information of the traffic types, car types, volume, mobilization requirements obtained by the installation of the traffic support officer, the ITO, or the installation of the Transportation Service Capability Study prepared by the Transportation Engineering Agency of the Military Traffic Management and Command, MTSEF. Chapter 3, establishing route and profile alignment specifications.